Unit 5, Part 2 notes. I can add and subtract polynomials. Match the like terms. So what I want you to do before you get too far into this video is I'd like you to organize this to where all the like terms are together. Now remember, like terms are those that have the same variable part. So for example, -6 and 9 would be like terms because they both do not have a variable. Likewise, 4x to the third power would be like terms with -9x to the third power because those also have the same variable of x to the third power. So that exponent there does make a difference. It is different than just being like x or x to the fourth power. So right now you can drag all those over. If you're writing on paper, you can write them down in the boxes, but put all the like terms in the same box. All right, so if you want to check your work, here are the answers, how they should all line up. And now the reason we're doing this as like an intro is because when we're going to add and subtract polynomials, you can only combine like terms. If you think back to when you were solving equations and we had the step CLT, that stood for combine like terms. So we're going to be utilizing that same skill of combining like terms when we add and subtract polynomials, which means if it has the power of x to the fourth, it can only be combined with other x to the fourth powers. It can't be combined with anything else. So let's practice adding and subtracting polynomials. So the first thing that you want to make sure is that your polynomials are written in that standard form. You want the highest exponent to the lowest exponent. So if I look at these guys that were given, they are already written in that standard form. So that's the first step. Second step is I'm going to rewrite these to line them up with my like terms. So I've got 2x squared plus 3x plus 4. And then I'm going to write the other one underneath it, matching up my like terms. So I have x squared, which I know is really just 1x squared, so I can write 1x squared underneath the other x squared term, plus 4x, so I can write that underneath the other x, and then plus 1. This one is really nice, lines up all nice and neat, and then we just add up our like terms. So 2x squared plus 1x squared is 3x squared. Add up the big numbers, but the exponent stays the same. We don't do anything with that exponent. And then our next one, we have 3x plus 4x. 3 plus 4 is 7, so we have 7 x's. And then plus 4 and plus 1, so 4 plus 1 is 5. And then that right there is your final answer. We're going to have a trinomial still, 3-term polynomial. It's just now we have combined all of our like terms. All right, let's do an example with subtracting. Same first step, we're going to double check to make sure we have our polynomials in standard form, which we do. We start with x squared, we go to x, we go to our constant. So now I'm going to rewrite my polynomials on top of each other. And we have 3x squared plus 2x minus 4. Now the big thing here is that we have to remember we are subtracting. So each time when we pair up our like terms, we're going to subtract, not add, like we did in our first example. So 5x squared minus 3x squared. We have 5, take away 3 is 2. And then we have 2x squared. And then we have 7x and 2x. But remember, we are subtracting those. So even though these plus signs are here, those are just saying those are positive numbers. And we are subtracting them. So we're going to do 7, take away 2, which is positive 5x. Now this last one, when we get to those negatives, they can be a little tricky. So let's make sure we understand this. Right here, this is -3 and -4, and we are subtracting those numbers. So we are really doing negative 3 minus negative 4. That's what that problem is reading as. And you are 100% okay to use your calculator if you want to. So if we take our calculator out and we go negative 3 minus negative 4, we get the answer of positive 1. So since my answer is positive, I'm going to put a plus and then the number 1. So that is adding and subtracting polynomials. All right, let's do a couple more examples of adding and subtracting polynomials. These ones are a little more advanced. They don't line up as nicely as the ones we did previously. So I'm going to show you a different way to add and subtract polynomials, a different method. So if you didn't like the first one a lot, this one might be more beneficial for you. You might like it more. So we are going to start with this pink parenthesis. We have negative 4x to the 4th plus 14 plus 3x squared. So I'm going to start with the first term there. I'm going to take that negative 4x to the 4th, and I'm going to look at the purple parenthesis and see if anything else has an x to the 4th power. Since it does, I have two like terms that I can add up. So I can do negative 4x to the 4th plus negative 3x to the 4th. Negative 4 plus negative 3 is negative 7x to the 4th. So now I've used those two terms. I won't be using them again. I'll cross them off. I go to the next term in the pink parenthesis, which is positive 14. So now I ask myself, is there another term that does not have a variable with it? And that would be this negative 8 right over here. So now I can do 14 plus negative 8. 14 plus negative 8, or just 14 take away 8, is a positive 6. Now I go to the next term, which is 3x squared. Now if I look over at the purple parenthesis, I don't have anything that has an x squared. So what that means is this is just going to come down and join my answer, plus 3x squared. It still exists in the problem, but there's nothing I can add or subtract to it. And then that same thing is going to happen with this negative 14x. There's nothing else that has just an x, so it just comes down and joins the answer. So now this is my answer. However, we do need to make some adjustments because it needs to be written in standard form, which remember is from that highest power to the lowest power. So what I'm going to do is I'm going to write my highest exponent, which is 4. My next highest exponent is 2. My next one is just the x, and then my last one is 6. You do want to make sure you're rewriting in standard form, because in the check-in questions and then the formatives, all the answers will be required to be written in standard form. So I want you to make sure you're practicing that in your practice here. All right, let's apply that same concept to subtracting polynomials. Let's subtract some polynomials. So we're going to start with this first term, 3. Look over at the purple parenthesis. Does anything have a 3? Or, excuse me, does anything have no variable with it? No, just the 3. So we'll just put a 3 down here in our answer section. And we'll move on to the next one. Negative 6x to the 3rd. Does anything else have an x to the 3rd? I can see that this does. It has negative 8x to the 3rd. So I'm going to do negative 6x to the 3rd. Now remember, we are subtracting, so it needs to be minus negative 8x to the 3rd. So we are going to do negative 6 minus negative 8. And again, you are more than welcome to use your calculator. Negative 6 minus negative 8 is 2. So since it's positive 2, I'm going to put plus 2x to the 3rd, because that's what the answer to that piece was. Done with my x to the 3rd, so I can move on to the next one, which we can see is negative 8x to the 2nd. And if we look at the purple parenthesis, we do have something else with an x to the second power. So we're going to do negative 8x to the second minus 6x to the second. Negative 8 minus 6 means we're going 6 more negative, so we end up at negative 14. Negative 14x to the second. So I add that to my answer. And then our last terms, we have 4x and negative 3x. So we have 4x minus negative 3x. Remember, double negative minus a negative becomes a positive, so this is really 4 plus 3x, which is positive 7x. Now this is our answer, but remember we do need to rewrite it in that standard form. So double check for standard form. So in this case, we're really close to having all of our pieces in order. This 3 is just in the wrong spot. So we're going to do 2x to the third minus 14x to the second plus 7x. And then that positive 3 is just going to be added to the end there. All right, that is all of your notes on adding and subtracting polynomials. You can go ahead and move into your practice, which has a little matching thing. If you are doing it on paper, you can show your work on this page. If you're working online, you can show your work on scratch paper or on the computer if that's your preference. And then there's a couple other practice problems for you to try. And then on the last one, it says write a polynomial for the perimeter of each figure. So remember, perimeter just means adding up all of the sides of a shape. So you'd add up all the lengths. So a little bit of a challenge here to add up all of these polynomials, but I believe that you can do it. And then lastly, make sure you complete the check-in once you've done all your practice problems. And as always, if you need any help or support, please reach out.